Hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So in the last session, we discussed about the particular integral of type 2. So the type 2 is nothing but q of x is equal to sin ax or cos of ax plus b or sin of ax plus b. So in this session, we will discuss about the particular integral of type 3 or the method 3, and so we will see the problem on type 3 of finding a particular integral. So what is the type 3 of a particular integral? The type 3 or the method 3 of a particular integral is q of x is equal to x to the power n or x to the power k. So we know that what defines the yp. So yp is defines 1 by f of d into q of x. So where q of x is nothing but here x to the power n. 1 by f of d into x to the power n. Then how can we find this particular integral? So to find this particular integral, first of all, you have to take the lowest degree term. So you have to take the lowest degree term common from f of d. So that means you have to take the lowest degree term as a common in f of d. Then later to get an expression of the form 1 plus or minus phi of d. So after taking the common, it will give the 1 plus or minus phi of d in the denominator. So and later you have to take it to the numerator. So after taking the numerator, it gives 1 plus or minus phi of d whole power minus 1. So now you have to expand this 1 plus or minus phi of d whole power minus 1 by using the binomial theorem up to the terms containing nth degree. Since n plus 1th derivative of x to the power n is 0, so that you have to take up to the terms containing x to the power n. So what's d stands for? We know that the d stands for the derivative. The derivative is nothing but d by dx. Then operate the numerator term by taking the differentiation. So what's the type 3? The type 3 is q of x is equal to x to the power n. You have to substitute x to the power in q of x of y of p. So yp is nothing but 1 by f of d into x to the power n. So to find the yp, first you have to take the lowest degree term common from f of d, and then later it will give the expression 1 plus or minus phi of d, 1 plus or minus phi of d into x to the power n. Then later you have to write in the numerator. So that term is 1 plus or minus phi of d whole power minus 1 into x to the power n. Then later you have to expand this 1 plus or minus phi of d whole power minus 1 by using the binomial theorem up to the terms containing nth degree. So why we are taking only the nth degree terms is since because n plus 1th derivative of x to the power n is 0. Then later you have to operate each and every term of the expansion, right? Then later you have to differentiate. So d stands for the d by dx. You have to differentiate. So that is the yp of the given function q of x is a polynomial. So right, so now we'll see some formulas. So those formulas are, so see the first formula is 1 plus x whole power minus 1. So all these formulas we are using in this yp. 1 plus x whole power minus 1 is nothing but 1 minus x plus x square minus x cube, and 1 minus x whole to the power minus 1. So if the given function is, this is of the form, this is the expansion you have to take, right? 1 plus x square plus x cube. 1 plus x whole power minus 2 is nothing but 1 minus 2x plus 3x square minus 4x cube plus and so on. And 1 minus x whole square is nothing but 1 plus 2x plus 3x square plus 4x cube plus and so on. But here we are writing in terms of d. So here I am writing in terms of d also. 1 plus d whole power minus 1 is nothing but 1 minus d plus d square minus d cube plus and so on. And the next expansion is 1 minus d whole power minus 1 So this expansion is 1 plus d plus d square plus d cube plus and so on. So here this is the whole positive series and the above one is the alternate series. The next is 1 plus d whole power minus 2, the same expansions but I am writing in terms of d. So this expansion is 1 minus 2d plus 3d square minus 4d cube plus and so on. The next one is 1 minus d whole power minus 2 is all positive series. It gives 1 plus 2d plus 3d square plus 4d cube plus and so on. So these are the expansions in terms of d. So now let us see one problem on this method when the yp is a polynomial. So here see the question is d square y by dx square minus y is equal to 5x minus 2. Right. So now let us see the solution. So before going to solve this, first you have to change the differential equation into the terms of operator capital D. So by writing operator capital D, this is d square y minus y is equal to 5x minus 2. So and now take the y common, d square minus 1 into y is equal to 5x minus 2. So now this equation is converted into the form of f of d into y is equal to q of x. So here 5x minus 2 is a polynomial. So we know that 5x minus 2 is a polynomial, so that we can use the type 3 of finding a particular integral. So before finding the particular integral, first we have to find the complementary function. So now to find the complementary function, functions, we have to take the auxiliary equation. So that auxiliary equation is nothing but the algebraic equation of f of m is equal to 0. So f of m is equal to 0. We know that what is f of d? In d place you have to replace m. So that is m square minus 1 is equal to 0. So now you have to find the roots of this equation. M square minus 1 is nothing but m minus 1 into m plus 1. M minus 1 into m plus 1. So now here the roots are m is equal to 1 comma minus 1 are the roots of this equation. So now write the complementary function yc is equal to c1 e power x plus c2 e power minus x. Since here 1 and minus 1 are the real roots and distinct roots, so that the complementary function is c1 e power x plus c2 e power minus x is a complementary function. So now we will see to find the particular integral. So now we will see the particular integral. So now to find the particular integral. So that particular integral is defined 1 by f of d into q of x, and here f of d is d square minus 1. Here the q of x is a polynomial 5x minus 2. So if it is a polynomial, to find the particular integral, so in the denominator f of d, you have to take the lowest degree term as a common. So here in this f of d, the lowest degree term is minus 1. So that you have to take minus 1 is a common in the denominator. 1 by, so by taking the minus 1, 1 minus d square into 5x minus 2 is q of x. So right before the minus of 1 by 1 minus d square into 5x minus 2. So now the denominator is converted to the form of 1 minus 5 of d. So this 1 minus 5 of d we have to take into the numerator. So minus of 1 minus d square whole to the power minus 1 into 5x minus 2. So now this is a polynomial, right? Then what's the expansion formula we have to use here? So here this is of the form 1 minus d whole power minus 1. So what is this expansion? By binomial expansion or the by binomial theorem we are writing this expansion. 1 plus d square plus d cube plus and so on. And now you have to apply the same formula on 1 minus d square whole power minus 1. And here we have the q of x is 5x minus 2. What's the power of x is 1, so that you have to take up to the d terms. But here there is no d. But first we have to write the expansion, the whole expansion we have to write first. So 1 plus d square plus d square whole square plus and so on into 5x minus 2. Right, so no required to take the d square, d power 4 and so on this expansion. So 1 plus d square plus d power 4 plus and so on 5x minus 2. So in this expansion there is no d term, we have d square and d power 4, so we can neglect here the highest powers of d square, d power 4 and d power 6, d power 8 and so on. So why? Because the second derivative of 5x minus 2 is 0. And similarly the third derivative, fourth derivative, everything is the 0. So up to the first derivative only this value exists. Right? So that you have to neglect these values. Right? This is minus of 1 into 5x minus 2. So now we have to multiply with this minus 5x plus 2. So this is the yp of the given function. So then now finally write the general solution. Now the general solution is y is equal to yc plus yp. So what is the yc here? So this is the yc. So yc is equal to c1 e power x plus c2 e power minus x. Then write the yp. Then now the yp is minus 5x plus 2. So this is the general solution of the given differential equation when q of x is equal to 5x minus 2 or any polynomial. So if it is any polynomial, so you have to follow these steps, then finally you will get the general solution. So what's the method we discussed in this session? So in this session we discussed the type 3 or the method 3 of the particular integral when q of x or f of x is equal to the polynomial is nothing but x to the power n or a polynomial. Then how can we find the particular integral is? So first of all you have to take the lowest degree term as a common in the denominator, and later you have to write so that denominator into the numerator. So that gives the 1 plus or minus phi of d whole power minus 1 into x to the power n. Then later you have to expand this by using the binomial theorem. So use the binomial theorem, then expand this. Then later you have to multiply with the each and every term of this expansion. Then operate. So what's the d stands for here? D stands for the d by dx. So that gives the yp of the given q of x is a polynomial. So the next session, so we will discuss the method 4 of finding a particular integral. So thank you.